By golly,
Yep.
is that it? Are we on?
Yep. So I think so,
Okay.
Ron.
I don't see the big little red thing that says we're on YouTube, but ho 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 anybody. Anyway, everybody, happy holidays. On this, our 147th program of the SBAU Astro Hour. It's a 1 hour vlog, which is like a pandemic with our ugly faces on the screen. Maybe they're looking a little better with the Santa hats, at least for half of us. And it's all for the astronomical unit, SBAU, South Coast of Central California's longtime telescope and astrophysics club. We get together. I'm your host, Ron Herron, newly elected vice president. Meet the newly elected
Re-elected.
yeah, re-elected after many years. We're in, let me tell you. We are dictators. We never mind. I learn a lot from these knowledgeable guys, my comrades on screen, getting into the Christmas spirit, and I'll introduce you to them. I call them the Brain Trust. You can watch us live on YouTube, I think. I'm not sure about today, but come to our first Friday meetings where we have great speakers, and on our second Saturday, as in over this past weekend, star parties, we gather together at the Santa Barbara Beautiful Museum of Natural History, and we're at sbau.org. This week, we are going to talk for December 11th through the 17th, with, I guess, winter solstice coming in about 10 days on the 21st. I got a new moon, allowing us to look at asteroid 4 Vesta, as well as Flaming Star Nebula. Ooh. And let's see, what about cataclysmic binaries? There's a new one. I'm going to learn about it. Sounds scary. I don't think we'd want to live around one of those. Going to tackle the mysterious cosmic rays. That's one of the first things I ever heard about as a kid in science class, cosmic rays. And now it comes back to roost. And what we may talk about, Halley's Comet has reached a vantage point. I think it's its far end, which is either perigee or apogee. I'm not sure which. We'll talk about it. Millions are going to be incredibly watching Betelgeuse wink out tonight, and it's not the anticipated big. Wouldn't it be great if the supernova happened during that 15 seconds? Let's meet the gang, and here they are, ladies and gentlemen. El Presidente, Professor for us, Jerry Wilson. Happy
Good morning,
season.
and we are live.
We are live.
Yes, we
Okay,
have
I
that.
just didn't see the normal little red thing there on the screen. Matt, married to Pat Forgy, and has been around many, many, many years with us. Chuck McPartland's on the right of me with his Santa hat, SBA outreach coordinator in charge of just about all the events. His wife is Pat, and she's taken on the new role starting in the new year of treasurer from Colin Taylor, but still got the merchandise. Tom Whittemore is with us, middle of my screen, former college professor up at Westmont. How you doing? Editor of
Fine, thank you.
the
Thanks.
newsletter, married to Maureen. And we also have with us Tim Crawford, who's married to Karen, resident lens and telescope expert.
No
And
hat, but a lot of chrome.
that's right. Well, you need a. We're going to take up a collection, buy you a Santa hat. You definitely need it. I'm getting a glare off the top of your head, Crawford.
Yeah.
And there's Bruce back with us. Bruce Murdoch, who's married to Bonnie, longtime supporter, telescope enthusiast, just happens to be president of the Santa Barbara Theater Organ Society. And you just jump right in if you're doing anything. Otherwise, we'll talk about it when it gets time to go down to the Arlington. All right, Bruce? Good to have you back.
Fine. We just put the organ back in place because it had been removed. The console had been removed so they could do the Nutcracker.
God, you know,
every year.
I'd love to go down there sometime, have you bring that organ out of the stage and have me do chopsticks on one of those. Gentlemen, let's do some silly stuff. This is the president's forwarded silly science cartoons that get us all going in a good mood. And I'll try to chime in with the ones he brings up. These are sent to us. Oh, okay. Hey, Six Eyes. Yes,
like
Virginia. Yes, there's even bullying on other planets with a less
I
fortunate.
didn't see that one.
You didn't get that one?
I
Yes.
probably did. I just didn't see it till now.
This poor
Could only be Gary
alien.
Larson.
Right.
Yeah, that's Gary Larson. Here's Stonehenge. Another theory. Was it an early ancient spaceport? You buy your ticket, stand in line forever, and there they are being sucked into a UFO.
Good.
I
Yeah,
love it.
good one.
All right. This
This
one,
I don't get.
there's a strange formula in there. Let's see what I had set up. Typo dots. Oh, no, that's not typo dots. Where is it on my screen?
This is a quadratic rule on a stool.
Yeah, I have that. Oh, elf on a
Yeah,
shelf.
yeah, okay, good, got it.
Oh, yeah. Instead of elf on a shelf, try this, a rule on the stool. And what is this? The
Quadratic
formula?
rule. It's from
It's-
differential calculus.
Right.
Oh, it's,
When
oh,
you
well, of course.
differentiate, yeah.
It looks like graffiti on a bathroom wall down at the beach that I saw.
Oh, no, it's right.
Yeah,
Is it
very
right?
high class bathroom if you're in there.
I got you. Well, you use that all the time. Okay.
You know, someone just explained to me what the elf on a shelf meant because it was new to my culture. And that was, you know, Santa sends out these elves to people as sort of a pre-Christmas gift. And they put it on the shelf in the house and it spies on the kids in the house and it reports back to Santa to help him refine his
All right.
naughty and nice list. So it's really a euphemism for being watched and spied on.
It was
Aha.
the first iteration of the Ring doorbell.
Yeah.
I love it. Here's the professor on the stage, another Far Side cartoon. It's
Yeah,
how we
this is-
got the old, it's how we got the old song. You may have heard of this. Down in Texas, they love this. So in general class, we find that the dynamic friction of the tensor light cone is actually negative, creating a local convergence of photons, which causes the stars at night to be big and bright. Bum, 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 bum. Deep in the heart of Texas.
Go Ron.
That's how it was done. I've been practicing on that one. Here's the one that's needs explanation. Typo dot. Well, not really. It's very simple. Space tip.
No,
RS
it's actually pretty good.
Yeah, okay. Well, I wonder if it's to scale.
Yeah,
Well,
that's
it's
the point of it.
approximately to scale.
Yeah.
Okay, but Saturn would be off the grid, off the sentence, wouldn't it? Off past
Yeah,
the-
Saturn's, you need another paragraph.
Okay, got it. Space tip. I love it. Good
So
stuff.
if you
I don't
ever
know.
lost it, go ahead.
No, go ahead. What were you saying, Tim? Somebody
Oh
was
no,
saying.
I didn't say it, but I didn't realize you just used the eyes in this phrase.
Yeah,
Yeah, exactly. So you need a longer sentence if you're going to get Saturn.
right.
Okay, then the other
You have
guys.
to use Times New Roman.
Or smaller font.
Yeah.
Yeah, right, to get it. Yeah.
Or War in Space for Pluto.
Yeah.
War and Peace.
All right, gentlemen, full screen, and Bruce has turned away, and he'll join us in a minute. Everybody's ready to talk about, among other things, cosmic rays, but we want to go out to the moon first. We're about to get a new one. We don't name the new ones; we name the full ones, don't we? But
Well, they name the new ones, but it's not a name, it's a number.
it's just a
Right.
number. Well, it's only a sliver anyway.
Well,
how-
Ron, new
Yeah.
moon is from Old English. That means no moon. It's
Yeah.
from Old English.
How
Oh,
long is it? How long is it dark? It goes from one side to the other. Crescent.
Right. We saw it come up this morning.
Mhm.
There was a lot of clouds, but Maureen got a really nice glimpse of it about 5:15.
It's only a couple of hours that it's sort of
Yeah.
so thin you can't see anything.
Yeah, reliably new. So
Okay.
this is the path of the occultation of Aldebaran Betelgeuse
Betelgeuse.
tonight or tomorrow morning. And I believe the tonight part is over here and then Mexico in the morning, but we are just around the globe. We are not going to see it here and it would be too far south for us.
I
So
think
we're
it's on the tip of Florida, Jerry.
Yeah, the very tip of Florida. It's about
Yeah.
5 p.m. our time that it'll be happening, at least in Europe. And it's only, it's minutes long. So basically at 5 p.m. our time.
okay.
But for objects
Tonight?
Yes.
Yeah. Okay.
for objects so distant, you'd think the parallax view would give a wider berth than that. Only a few hundred miles and you lose it.
Well, the
It's
shadow is the size of the asteroid.
Yeah. Essentially, because
I
the
know, but-
rays come in parallel.
On both sides of that double line and going across the Earth, does it just sort of dim a little?
No, not at all.
It's not like a partial eclipse.
No.
No.
Really? It's either
Well,
gone or
in this
not.
case, you might get like a ring of fire eclipse because the asteroid is elongated. And depending on how it's rotated, you could get it to where some of Betelgeuse shows around it. And that would be
Wow.
really interesting if people are
Yeah.
getting.
Wow.
Chuck, don't you wish you could do that? You could be there for this one?
Well, see, almost everywhere they're having cloud problems, unfortunately.
Oh, oh.
I had one this morning at 3 a.m. and it was looking good right up until 2, and then bang, here came the clouds. So
Yeah.
They
You
all
could have
think
seen
it's the-
Arcturus come up, Chuck.
yeah.
I saw Arcturus come up at 2:44 this morning, just
Yeah.
over the hills. Yeah.
You didn't get much sleep last night, did you?
No, I just get up and look at the stars and then go back to bed.
Okay.
I do the same thing about when I'm going to bed, which is like about 2 or 3 a.m. And the last several nights, not last night, but not the night before, the sky has been sterling. It's been dark, and you can see. My guide is, can I see Lepus before Lepus? But I'm sorry, below Orion. From
Well,
my
good one
location,
is-
I can.
good
It's
one is-
okay. We got pretty good seeing.
Are we going to the Flaming Star Nebula, which is IC
We're going to Vesta
4050 Vet? We're going out to another asteroid.
Yeah. tomorrow night at 10, although
Oh,
it's going to
this
be
is
the
the
same night
asteroid.
at 10.
Okay, got it.
So there's Vesta right there.
Yeah. Ron, just a question
Vesta.
for you. If you
Okay.
live in New York City, how do you say Vester? Vesta.
That's true. They put R's on the end of A stuff and take them
Yeah,
off
Vesta.
regardless. Yeah. I heard
Thanks,
John
Chuck, for
Kennedy.
laughing.
Well, this is great for the rest of the world, but not us, or at least a little skinny line across the planet. So you guys aren't going to set up your instruments tonight or tomorrow night. Is it tomorrow night?
No, it's tonight, 5
What
o'clock.
is tonight? Okay.
But it doesn't cross our location, right?
Yeah.
It's not
We
gonna
won't see it at
cross-
all.
Yeah,
But
we don't-
there is a live feed from Gianluca Massi in Italy that you can click on the link and watch it live from Italy if they have clear skies, but it's bad.
Does that ever happen before Betelgeuse got occulted?
Not to my knowledge, but there was an occultation of Rigel a couple of years ago, which would have been naked eye visible also, but it was clouded out for us.
Wow.
It was on a path going across New York City, so everybody was real excited, and then it just got clouded out.
So
I
I
don't
guess
I don't know about New York City, but when we were in Chicago, I look up at the night sky and it's just orange. I couldn't see a single
Yeah.
star.
Whole sky, yeah.
yeah, they don't sell many telescopes in New York, at least not in the city.
You had to go upstate New York, yeah.
How big is Vesta?
Pallas Juno Vesta. It's Ceres Pallas Juno Vesta. It's going to be a couple of 100 miles across, or
Yeah.
around 100 miles across, somewhere in that neighborhood.
Yeah.
Well, it'd have to be to obliterate a red giant, wouldn't it?
No,
Well,
the red-
this is Vesta is not the asteroid that's occulting Betelgeuse. This is just showing
Oh,
you
this
that
is
Vesta's at opposition and it's fairly bright right now.
the asteroid that's occulting Betelgeuse is Leona.
Oh, okay.
And
I didn't
Leona's
get
pretty
that.
small.
Yeah.
Okay, got. All righty.
But it has occulted many stars before, so they have a good size estimate for Leona.
Yeah. And a shape model.
Yeah, that's true. So anyway, here looking at another asteroid, Vesta. It's just off the tip of Orion. This is Betelgeuse here. You can see it's not anywhere near, but it is passing by a couple of deep sky objects. And since we're real close to the new moon, it's a good time to look not only at Vesta, but at a couple of nice deep sky objects. And this one closest to it is NGC 2174. Does anyone know the colloquial name for this nebula? It's called the Monkey Face Nebula.
Oh, wow. Yeah, I
Yeah.
see that.
Wow.
Yeah, if I squint, I guess I can see that. Yeah.
Mouth, eye, nose looking up this way.
It's pretty
Kind of
good.
looks like Tom.
Does it actually look that way? Are the edges so abrupt?
Well, this is something pasted into a planetarium software, so it may not look like that, but there's a photo of it here.
Oh yeah.
Now this is completely rotated. It's upside down and backwards compared to the drawing in the planetarium photograph, but here's the mouth and here's the face. It's also got a small star cluster associated with it. But this is under these sky conditions right now, assuming there's no clouds, which at my house there is clouds. It's an easy object to see. People have seen it in scopes as small as a 2.4-inch telescope.
Really?
Yeah. And when you talk about 2.4-inch telescopes, that immediately tells me that was the entry level of refractors, F-15 refractors in the 50s.
Unitron.
Unitron, that's it. Yeah.
Unitrons, yeah.
And so that was one of the most popular scopes for visual
Right, they're
observation.
highly sought after now, right?
Yeah, people
Yeah,
collect
more or
them.
less.
Yeah.
Collectibles, you know, the phrase now about Unitron is they're better to look at than look through. They have their, in order to get the color corrected, they had to be their Fresnel combinations or designs. And so the focal ratio has to be real long. So it's a very narrow field of view and it doesn't make a real bright image.
Yeah.
But I find it hard to locate objects in that unless it's something real bright like a planet or a moon. But once you get it in there, it's a nice sharp image.
Well, Professor, a couple questions about the numbers you sent me. NGC 2174, is that the nebula? And NGC 2175, is that the monkey head? Or
No, 2175 is the
star cluster?
One's the cluster.
Right.
Yeah.
So there's a star cluster inside a nebula. And I guess that's
It's lighting it
that's
up and
right.
making it visible.
Yeah.
okay. Well, where's the star cluster? I see some stars, but
Oh, there's just a little congregation of things around here. It's not a real dense star cluster.
well, that's why it's an
Open
open star.
cluster, yeah.
Yeah.
Jerry, is this a planetary or is this just an
No.
emission?
This is just an emission.
Okay.
And maybe some reflection from that blue.
Yeah,
Yeah.
maybe.
Well, now I had it when I look up pictures on the internet for this, they were deeply green like this, or they were real brilliant red. So the colors are always artificial in a sense. It's not what the human eye would see. People are interested in certain chemicals when they take these pictures a lot, if they're scientists or it's a big observatory. For example, the Hubble telescope does not have filters that correspond to what amateurs regard as RB and G, or red, blue, and green. So it's a little tricky to get together an RBG image from Hubble data, because the Hubble data is centered on certain scientifically interesting spectral lines.
Huh. Well, now is the Crab Nebula nearby? That old M1?
Yes, it is.
Okay.
We were
is
showing
nearby.
that at the Star Party on Saturday.
Yeah.
Was it visible?
Really?
Crab
Wow.
nebula?
Yeah, you could see that real easy. Right there's the Crab Nebula, M1. See, here's Arctura or Vesta, here's Betelgeuse. Right up here is the Crab. Here's Aldebaran and Taurus. There's the two big horns of the bull. So the Crab is very nicely placed right now.
The
Now,
little star hop for that, Jerry, is it the horn that's closest to Orion? You just take that outer star and then you go inwards towards the head, and that's the hop. It just in other words, I always suffered from going all around that star, never seen anything, because it's real subtle through a telescope.
Yeah, that was my
planetary
point
nebulas.
Bruce?
Yeah, so that was my point too. When I've looked at M1, I can see it, but it's indistinct. It's, you know.
Yeah, but if you've got a Mellencamp on 28-second integration.
Yeah. Okay.
I have visual trouble with all planetaries because I whip right over them because they're so small. They're almost star-like unless you're at a high power. And I'm looking for them at a low power, so I get a wide field of view.
Oh, yeah.
So basically this barely able to see thing in the sky is the first thing Charles Messier named?
Yep. Well, he was
Oh,
looking for a
really?
comet and he came across a fuzz patch and
Yeah.
wrote it down.
Okay. Did he know what we know it as,
No.
a nebula?
Oh, no. Oh, no.
Well, he called it nebula. That just means cloud.
Yeah.
Well, that's what nebula are, right? They're
Yeah.
gas and clouds.
Well, they used to call galaxies nebulae too, because they didn't know what they were.
Right.
Okay. And nebula can be the leftover of a bunch of stars exploding or the birthplace of all kinds of new stars. Or either way, that just a big
Yep.
gas field.
The Crab
Where are you
Nebula is the
taking-
only supernova remnant in Messier's list.
Oh, is it?
It is. It is.
Yeah. We call so it's not a true planetary.
No.
But it's the
Okay.
size and shape of one. It's our term nowadays in the club is faint fuzzies.
Yeah.
That's what nebula meant 200 years ago.
Looks like a splash of milk in a big scope.
Yeah.
With filter.
Are we jumping ahead to the
Yeah, we're jumping ahead to cosmic rays because you
cosmic
always ask
rays?
about these things.
Aha.
So
Here
this
we
is
go.
this is an artist sketch of cosmic rays hitting the atmosphere.
Only 4?
In this picture,
Visually, do you see these? Do you see anything in visual light when they hit the atmosphere?
you can.
Mhm.
You can. Let me just get to that part.
And actually, when it hits your retina, you can get a flash, even though you're not, you're seeing it a little differently.
Well, the astronauts had that problem.
Yeah, because they were up in above our protective atmosphere. The atmosphere and our magnetic field shield us effectively from this.
Say that
So-
fast twice.
Yeah.
How do they differ from neutrinos?
You can't see neutrinos.
Yeah.
They go through you. Thousands, I forgot the number, but a whole lot of them every second.
These cosmic rays, Ron, are essentially atomic nuclei at really high speeds, whereas a neutrino is a subatomic particle that's really, doesn't like to interact with anything.
So a naked atom, like a proton, which would be a
Yeah.
hydrogen,
Yep.
is on its own, looking
Yeah.
for an electron, or it's
Yep.
just cast out near the speed of light.
Yeah.
Yes.
Oh,
Okay.
and that's another question I got Saturday night. Does everything have a mass? And I said, well, maybe a neutrino doesn't.
Well, no,
Light
they do.
doesn't. Light
And
waves.
everything has a rest mass, or not a rest mass, but a mass. E equals mc squared. So even energy has a mass.
Oh,
effect.
okay. That
Right.
does it right there. Yep. Okay.
Well, my understanding was light is just pure energy and it never is mass.
No,
Well, E
It
equals
has an
H
effective
also,
mass.
so you can figure it out that way and create the two.
But this picture denotes that we can see the arrival of some of these cosmic rays.
You
Yeah.
can.
With the right detector.
This is from the from an Earth viewpoint. This is also an artist's rendition, but it's what's called a cascade. So a cosmic ray, being say an iron nucleus, comes in and it hits something in the atmosphere, say an oxygen atom, and it just blows the whole thing apart into this stream of elementary particles. This is where the muon and antimatter were discovered, is in these streams.
Whoa.
In Switzerland, we have the CERN collider, which accelerates particles to very high speeds and then slams them into each other. And they look at what comes out, all the wreckage and the stuff that flies out. And that's where we do our elementary particle studies. The cosmic ray is a naturally occurring collision device like that. So they come in at such high velocities that we get energies from these streams that we cannot produce here naturally in a lab on Earth. And so that's where we find a lot of these things, by putting detectors down on the ground or in the air to see them. It turns out that people that did work in the laboratory with electronics back in the 1700s occasionally noticed that their experiments were doing odd things. Sometimes they'd have energy stored in a Leyden jar, and I'll explain what that is in a second, a big capacitor, and all of a sudden it would discharge. And So there were these mysterious things, and scientists over the next century and a half narrowed this down. They knew there was some source of radiation that occasionally interacted with particles in their experiments, but no one was sure where they were coming from. And the candidates were the Earth's crust, the atmosphere, the sun. Turns out most of our cosmic rays come from the sun, but a lot of them come from much farther out. In 1912, Austrian physicist Victor Hess flew a balloon to an altitude of more than 17,000 feet, where he found that the radiation rate increased significantly. He concluded that the cosmic rays must be coming from above the atmosphere, and he was awarded the Nobel Prize in 1936 for his observations. It wasn't just that he went up in the balloon, he took a lot of instruments with him. That is, he was actually looking for this effect. So not only do you have to discover something to get the Nobel Prize, but you have to know what you discovered, and you have to know how it fits in with all the other current theories and stuff.
Geez, he went up in the balloon as well?
Yeah, he went up too. Yeah, there was no way to
goodness.
transmit the data. They didn't have, data links.
Whoa.
So
cosmic rays are part of the solar wind, and that is dangerous to our astronauts going to Mars because of radiation. Is that what we're basically
that's correct.
talking about?
And people that fly a lot in the Million Mile Club and pilots, they are more susceptible to radiation-induced body damage, cancer, and stuff like that. Very slightly more than people that stay down on the bottom of the atmosphere.
So it's naked protons that's doing it.
Well, no, everything, all the stuff that's doing it is naked protons are, of course, the dominant solar wind particle. It's hydrogen with the electrons stripped off. But there's other nuclei too.
Well, what comprises radiation then? What leaves the atom?
Radiation is high-speed particles or energetic light.
Yeah.
But there's all kinds of particles. Light really isn't a particle, but
it's something that radiates out from a source.
Yeah.
And those sources
somebody hitting you with a bowling ball, that's like radiation, but at a real crude level.
Yeah.
Well, you have non-ionizing radiation and ionizing radiation. Right. And it's the ionizing radiation that's dangerous to us.
Yeah.
I have no idea.
Damages our equipment.
Right.
In semiconductor devices, you have silicon oxide and silicon dioxide between layers of metal and semiconductor, and they're there to be an insulator. And if they get hit with ionizing radiation, that produces a charge center in the insulator. And so now the insulator is not only insulating, it's biasing a local region of the semiconductor, and it can build up many charges. They're called fixed charge centers. They can eventually short the device, or they can just simply bias the thing out of its working range. So semiconductor electronics, solid-state electronics, is very susceptible to radiation. And data transmitted by these particles or by these instruments is very, very susceptible to information damage. And we'll get to that in a minute. This shows...
One thing, Ron, the camera, the Mellencamp camera that I use at the outreaches,
right?
Okay, that's almost 20 years old now. And if I turn it on and I have the cap on the front of the telescope, so it's looking at nothing but darkness, there's still a pattern on the screen that looks like a bunch of stars. And that's cosmic ray damage. That's rays that have come through and hit that detector and damage the pixels so that they always look like they're on from this bias that
interesting. I would never known that.
Okay, so these rays do come from probably all the stars. We just happen to be the closest to the sun.
That's right.
We get more of that, obviously, far more than you would from Vega or whatever.
Plus the magnetic field of the sun and of our planet divert a lot of them.
And your point about the CERN moments ago, Mr. President, was that's the same stuff they shoot down that big circular 17-mile track, isn't it?
They're more selective about what they shoot.
Okay.
Boy, the guys that grab onto those little particles and put them in, they gotta have some really clean hands.
Well, when they were first starting the CERN stuff, there was a group of people that were worried that they would ignite the atmosphere.
Oh yeah.
Well, that was the first atomic bomb too. But with
Yeah.
Oh yeah,
They-
of course.
That was
they were
Fermi's
worried that
joke.
they would create small mini black holes that would end up sucking up the Earth.
Yeah,
So they
Well,
want to also spontaneous reaction, I think.
yeah. Matter of
remember
fact,
when we had the CERN expert on? He's a professor here, but he's part of the CERN thing in Europe.
Switzerland.
I meant to ask him a question and I didn't get around to it, but I can ask it now. The big 17-mile long circular tube is all the air sucked out, isn't it? They try to get as much of a vacuum as possible.
Yep.
And then I'm imagining that the electromagnetic whatever around the edges are all positively charged, so that it would keep the protons in the middle,
Well,
right?
it's magnetic. It's
They use the magnetic field. Yeah.
Okay, but you can do a magnetic north or a magnetic south. That's positive and negative. And if you got north, which
It's not
is
quite the
positive,
same as positive and negative, but yeah.
Yeah, you got a little bit of a misconcept going there. The magnetic field is in the CERN, picture it as a big circular donut. And the magnetic field is going straight up. And so when a particle is injected into the magnetic field, it makes an arc. It makes a circle in that magnetic field. It wants to go in a circle by the Lorentz force, which is a cross product. Its force is equal to velocity crossed into the magnetic, or the magnetic field crossed into velocity.
Yeah.
QV
Times the charge.
Yeah. So it goes around in a circle, and that's how it gets it from running into the sides of the chamber. It's not that the chamber pushes it back into the middle. It's that the magnetic field going up and down continually accelerates it until it goes
that was
fast.
done with klystrons with RF energy, and then there's a quadrupole magnet that keeps it centered in the tube.
Right.
Huh. I just thought it was the same poles, north.
No, there's 4 poles. There's two north poles that oppose each other, and 2 south poles, I believe. So no, the other way around. Pardon?
You can't have a magnetic pole. Magnets always come in 2 poles.
Yeah, so they oppose each other, north south.
Yeah, it's like pushing 2 ends of the same magnet together, and they're both positive. They won't go together.
Not positive, negative. It's north south, and it's different thing.
Yeah,
but they were okay.
Okay, we'll have a diagram next time. I'll show you the Lorentz force.
Please, thank you.
So this is space people in what is this? This is NASA astronaut Drew Morgan spacewalking to perform maintenance on the Alpha Magnetic Spectrometer, an instrument that detects cosmic rays, and it's on the International Space Station. The magnetic rays are not, or the cosmic rays are not from the space station. So these are the observatories that we use on Earth to detect cosmic rays. The Pierre Auger Observatory, and in Western Argentina, consists of water tanks, and they pretty much look at the collisions again and rely on collisions. The first way we detected these things, aside from noticing it was screwing with our instruments, was we built cloud chambers in the 30s, and you can see a cosmic ray go through a cloud chamber. And if you want to have as your part of amateur astronomy, you want to do cosmic rays, you can build a cloud chamber very easily in your garage. They're safe, and you do catch cosmic rays with them.
What's the cloud?
The cloud is, you have an atmosphere inside that is super saturated with humidity, very high humidity, and an ionizing particle goes through the atmosphere, and it condenses a trail of a little cloud of little droplets of fog that follow it through. And then it quickly dissipates back into it. It looks like a little bullet path going through, and then it dissipates. But you can take pictures of it. We've all seen that stuff in science fiction movies from the 50s.
And the Griffith Observatory, if you're in that big gallery there, they have one of these cloud chambers, and you can stand there and just watch as cosmic rays come through and hit it.
I'd forgotten about that. Thanks.
Wow.
So we have a high altitude air shower observatory in Sichuan, China, spread over 300 acres. the International Neutron Monitor Network all over the world with more than 50 instruments, the High Altitude Water Cherenkov Observatory in Mexico, Telescope Array Systems Veritas in Arizona, the Ice Cube Observatory in Antarctica, where they've got a cubic geometry of sensors lowered down these holes they melted in the ice with jets with hoses of steam, and then it refroze. And so, but they're all in a cubic array, so that's why it's called the Ice Cube. Very clever. Satellites such as China's Dark Matter Project Particle Explorer, or the DAMP, Voyager 1 and Voyager 2, which are now outside of our solar system, but they're still sending back data to us, and the NASA's Parker Solar Probe as it loops the sun. These are all set up to detect hits from cosmic rays, like Chuck's camera, and send them back, send the information back.
Jerry, there's a detector of some type in Japan that's way down, and it has
the Super Kamiokande, yeah.
Is that only for neutrinos, or would it?
Yeah, that's primarily neutrinos.
Okay.
Well, Harry Nelson from UCSB has got a big thing. I think it's in more in the northern states, way down in a mine.
Yeah, up in North Dakota.
South Dakota.
South Dakota.
Right.
And the
I had a
Kamiokande,
50-50
Tim, the Kamiokande is buried because they don't want to see cosmic rays.
Right.
Oh.
Just neutrinos, yeah.
Cosmic rays don't make it down
And
that
the
far.
same way about the mine in South Dakota.
Yeah.
Huh. So the bottom line is cosmic rays can be dangerous. Neutrinos aren't. They mostly go through us.
Yeah. Yeah, cosmic rays, it's not a big problem for people unless you're a space astronaut. Mostly they're dangerous for us with our electronics gear and data transmitted from probes. We get data errors from these different effects, where a satellite data can be prone to bit errors. A single cosmic ray can change a bit in a binary data stream, not once it's transmitted, but by hitting the electronics that transmit it at the wrong time. So it changes it for a moment from a 1 to a 0 or a 0 to 1. So where I worked, we always sent our data like this back down to Earth in triple encoded data streams. For example, if we want to send the bit or the byte, I think it's 6 of them, should be 8, but anyway, 010110, we write it as triple redundant. So it's 3 zeros, 3 ones, 3 zeros, 3 ones, 3 ones, zeros. And that way, if a bit error occurred, it will not fit the pattern. And you can tell from its neighbors what it should be. And so you correct it. And that's how data is transmitted between satellites and Mars and the Earth.
So could these cosmic rays affect like self-driving Teslas?
Anything electronic.
Yeah, anything electronic.
But to override that, if they could they also have some kind of like a correction, like what you've done here, that's triple data, and it would protect it from interfering.
Only if you're transmitting data, but if you're reading code, it could have changed the code.
Keep your hands on the wheel.
Well, they have some error correcting methods in the spacecraft electronics.
Yeah.
Well, they also have them on CDs. For every 128 bits of data, there's 160 bits transmitted.
Yeah.
A P word, a Q word, a CRCC word. And
they have checksums and things. Yeah.
They can detect and correct. I forgot how many errors in a row.
But back to my original question about radiation, are the cosmic rays the ones that would be carcinogenic?
Yeah. Ionizing radiation.
Yeah.
That's what we're worried about.
X-rays will do it too. That's why they throw this lead blanket over you when you get your teeth X-rayed. So you can, still have babies later.
You should have some kind of clue when they walk out of the room.
Yeah. Here's just a pretty picture of a circular rainbow taken by a pilot from 33,000 feet. But I think I've shown this before a previous time.
Yeah. That's amazing.
It is
very. You have to be up high.
Yeah.
The ancient man never knew that, did they? Never knew there was more than
Standing on a hilltop, maybe.
Yeah, you get
Oh.
what's called Brockens or auras around you that can look like that, but you don't get it just by itself in the atmosphere very easily.
Okay, where are we going now? Into the space.
Okay, this one, there we are, the Monkey Man. This one we're going to look at. This is also 10 o'clock, and it's moved over just a little bit. It's interesting. Here we are a little higher in the sky. This is Taurus up here, and this is Auriga, I think. And right here is IC 405. So IC 405, and that is a emission and a reflection nebula given by this, and it's illuminated by a single star, this one right here, which is a variable star. And what did I do with my cheat sheet here?
This is the runaway star, right?
This is the runaway star.
Are we talking cataclysmics? Or have we reached the cataclysmic pairs yet? Or is
So
that
we're taking the cataclysmic star. We got to go back.
Oh, well, we
I
missed
think so. This is the Flaming Star Nebula, and that's the star in Auriga. The it's 6 magnitude variable. It doesn't vary very much. It goes between 5.4 and 6.1. It's an average of 6. But let's see right here. It's a blue O-type main sequence dwarf. It's very hot. It's very high surface temperature. It's an Orion type variable star. It's 1,300 light years away from Earth. It's a runaway star that may have been ejected during a collision of 2 binary star groups. This collision, which also created and is credited with ejecting Mu Columbae and possibly 53 Ariatis. So it sounds like a real traffic jam. That got a lot of things ejected, but the collision occurred in the trapezium cluster in the Orion Nebula 2 million years ago. So they've traced these stars back to a single point, and it's in the trapezium.
Huh.
The binary star Iota Orionis may have been the other half of this collision.
half of a collision?
So,
what is IC?
AE Auriga is passing through at a high speed, and it has a violent shock wave, which is not shown here, that it's preceding it. Very interesting.
Colorful. I wonder where we got that, Hubble.
You were asking about IC. IC means index catalog.
So that's a totally different one from NGC and EMS, right?
Yeah.
It's generally NGC was started by, what is it, Herschel?
Yep.
And in the 1800s, once we got really big telescopes that took photographic images, we saw a lot more fainter nebula and things. And so they started the IC catalog to cover those things rather than just add them to NGC.
Well, I don't see too many of them. It's all Messier objects or NGCs.
That's because these are really faint, and amateurs, basically photograph them more than they look at them.
Yeah.
No, Shane, what's the name of this again?
The Flaming Star Nebula.
Flaming Star, okay.
Well, could also call it the LGBTQ. Never mind, we're not going to get there.
Yeah, it's right here near M38, near LF in
Taurus.
It's shared. That star is shared. It means the butting in Arabic.
Elnath.
And you can see
It's shared by Auriga. Yeah, it's shared by Auriga and the bull.
Mhm.
Tom, that Elnath, that's what Elnath means?
Elnath means the
Elnath.
butting. Yeah.
Huh, I'll be darned.
Like
Now,
butting heads together.
With a full moon, we wouldn't be able to see this?
No.
No.
Really? It only comes
These
out.
are dark sky objects we're showing tonight.
Yeah.
Great.
That's even tough in an 18-inch.
And it does take time to get a good picture of them, doesn't it? You got to leave the damn thing on and hope the tracking, or trust the tracking to stay on it as the Earth moves.
I take subframes and I take either 5 or 6 minutes subframes.
Yeah.
And I take between 12 and 20 of them to stack them up to get a picture of things like this.
Yeah.
So
Well,
it's
much more dazzling are those open clusters that run right through Auriga. 36, 37, and 38. Notice the numbers are flipped a little bit. Okay.
I wonder if an amateur
Yeah,
telescope,
37, 36, and 38.
Those are wonderful open clusters.
Open clusters.
could an amateur do a deep field of several days? It'd be impossible, wouldn't it?
No, it's just, it takes diligence.
Yeah.
But your tracker, even during the day when it gets
No,
light,
you just go back on it the next night.
Yeah, you shut down, go sleep during the day, and you can even program your observatory to do it. You don't even have to attend it.
Yeah.
That's a sin.
but you
But
need a Hubble
you
or-
suffer from light pollution that starts to overwhelm what you're getting.
Yeah.
Okay. So we're not going to get really good deep fields except for the Webb and the Hubble.
No, some people have their own observatories high in the mountains or way out in the desert, personal observatories, and they can get
Or even in their backyard.
yeah.
Okay.
Of course, more subject to the weather there.
Uh-huh.
Oh, the Geminids.
Here's one of those horrible astronomy magazine star charts. God.
Yeah, I figure it's going to be it's good enough for us tonight, but every time I come across one of these, I think of Chuck.
So we're looking at the radian, right? Gemini?
Yeah,
A bicaster at the top.
right.
This picture applies December 15. So what is that, Thursday
Yeah.
at 1 a.m. local time?
Mhm.
The Geminid meteor shower.
Yeah, so it could be up to 150 meteors per hour.
Yeah,
Maybe
right.
it's up to that, but it's more an average of 50 meteors per hour, so roughly one a minute.
And you'll have a dark sky, which is
Yeah, and we are going to have a dark sky this time for it.
But most of the predictions I've seen for the time of the actual peak puts it at 11 a.m. our time. So bad news there.
Yeah, bad news on that one. Yeah, it's
We're
not
starting-
it's not one of these that spans several days.
right.
Well, we're going through somebody's former tale of a comet.
Yeah, this is from actually what they think is a nearly defunct comet / asteroid called Phaethon. It's actually mostly rocky.
Right. Yeah.
That's why you get some good fireballs.
Does it still come and go?
Oh yeah.
It's like Halley's. You sent out a picture, Mr. President, of Halley's at its most distant turn,
Oh, yeah.
ready to come back in about, what, 40 years?
2061.
Oh, I didn't include that in this list of photos, so I can't show it here.
I think it has a period of 76 years.
Yeah,
So
76 years.
I've got it. Do you want me to screen share it? You sent it out.
Yeah, go ahead.
All right, let me go grab it.
Well, let me ask about comets here. Do they retrace the same exact orbit, or do they take a totally different path? They swing around the sun.
Depends
that.
whether they've messed with Jupiter or not.
Yeah, gravitational thing, but also when they get near the sun and they start producing a tail, they're acting like little rocket engines, and so that slightly changes their course. So there's a certain amount of unpredictability for that.
Really?
Yeah,
The moisture on the rock that's being expelled pushes it forward?
Yeah, it's like
yeah.
a rocket.
Matter of fact, one of the ideas to move a small asteroid, if it's heading for Earth, is to go up and paint one side of it white. And then the photons bouncing off the white side will actually impart a certain amount of momentum that over a period of time, and you need a lot of time, it will move it off to the side.
Rather
I
than leaving,
put it up here. I don't know if you guys can see it, but
I
Yeah,
there's
we see it good.
Yeah.
So this
Well,
has
they even
special this has special memories for me because I saw the comet in Tucson, Arizona when I still there's a grad student. And it was 38 years ago that I saw it. And 2 times 38 is 76.
Yeah,
but there are scores and scores of comets. This is the only one the public really knows.
it's probably the most famous. It had the biggest scare for our great grandfathers.
yeah.
In 1900, when we actually passed through the tail of Halley's Comet,
Yeah.
and astronomers were using spectrometers for the first time
Yeah.
on a large scale, and they said that the tail was full of cyanide gas and other things. And so these people started selling gas masks for when something.
Yeah, and pills too, Jerry. They sold pills.
Comet pills, yeah.
But looking at this picture, gentlemen, Halley's orbit is not exactly on the sun's ecliptic, is it? And the ecliptic of the planet. That's what that
No, this
fence
is
looks
below
like.
the ecliptic, and you see these lines going up and down. That's the projection here onto the ecliptic.
Mhm.
So the
And it's a
orbit is
retrograde
underneath.
orbit too, so it's going in the
Yeah.
opposite direction.
But would it be from the Kuiper Belt or from the Oort cloud?
This one doesn't get out that far.
Yeah,
See,
but it
this
could
is-
have originally come from those, but then
Yes.
Jupiter modified the orbit, and so it ends up as a short period.
Huh. Kuiper Belt is like a big donut. The Oort cloud is a big eggshell.
Mhm.
So I
Yeah.
guess wide enough to be off the ecliptic here. Interesting. Well, I hope we're still around to see it come back. I don't think so, though.
40 years from now, I'll be
Never know,
123
medicine's getting
years
very
old.
good. Yeah.
With some titanium parts, you might still be around.
Yeah, hold your breath on that one. Well, thanks, Chuck, for that. Fascinating stuff. What else did he send? Oh, yeah, okay. Tonight's Betelgeuse occultation. But how many of you go out and watch these meteors and count them and everything? Can we see them here?
I sometimes go out and do it. My favorite instrument is a chaise lounge,
Right.
and I lay there with a blanket on and try not to fall asleep. But I sort of quit doing that about 5 years ago when my son and I were doing it, and we were looking up, and he said, "Oh, there's a good one." And I said, "Where was it?" And he pointed right where I was looking. I realized with my eyes, it's not worth it anymore.
But the all intenseful, useful instrument that we all have is totally useless for watching meteors. There's no way you can put up a telescope.
Well, the other night when I was out looking, just before bed, I guess it was 2 or 3 in the morning, there was a bolide that came in. It was very bright.
Yeah, those are nice.
A what that came in?
What's
a
that?
large meteor.
A fireball.
Oh,
Did you
Boloids
see
are
that, Bruce? Did you see that in the Northeast?
No, that was south
Okay, I saw one in the
over
Northeast.
the ocean.
Yeah.
Somebody Saturday night saw a good one, and
Yeah.
and I think it was in the Northeast.
Yeah.
Yeah,
Oh,
that might be the one I
sorry.
saw.
Northwest. It was
But
northwest.
mine was, probably 1 in the morning or something like that.
Yeah.
Boloids are big and bright and slow, and they're frequently red or orange, and sometimes they even have visible flames behind them and leave smoke. It's just like a cheap special effects in an old movie.
Yeah.
But they're very dramatic.
Yeah.
So
Well,
this is, go ahead.
I was just going to ask about ancient man finding the early meteorites. That's the first time metal was ever held in their hand, wasn't it?
Probably.
Potentially.
Okay, go ahead. Sorry to interrupt.
Oh, and that's okay.
What happened here?
This is what we're going to look at, a very nice, popular, and easy amateur object, Messier 64, also called the Black Eye Galaxy. It's in the distinctive constellation of Coma Berenices.
Mhm.
So, and that is over here. This is the region of the Virgo cluster.
Mhm.
And this will be overhead more in the springtime, but right now it's in the early morning.
Mhm.
And it's a nice object to look at. This is a Hubble picture of the black eye. In a scope, you don't see this detail, but you can see the brightness and then the darkness next to it. And it's a fairly complicated galaxy. It's magnitude 8.5 and about 10 minutes across. So it's easily in the size of small telescopes for us. You really need to look at with a 10-inch or more.
And they also call it the Sleeping Beauty Galaxy or the Evil Eye.
Yeah, it's also the Sleeping Beauty Galaxy or the Evil Eye Galaxy. It was discovered by Edward Pigot in March 1779, and independently by Johann Elert Bode in April, same year.
That's Bodie, right?
What's that?
Bodie.
Bodie, yeah. And Bode has another galaxy
Bode.
too called Bode's galaxy. In
German.
Yeah. So Charles Messier discovered it the next year.
Gave it an M number?
Yeah.
Yep, he gave it the M number.
64.
Yep.
I wonder how
Jerry,
got...
an 8-inch scope would not be able to resolve this?
You
can see a faint fuzzy. You know, resolve is a word for bright objects. This is a very dim object. 8.5. It's 2.5 times beyond naked eye visibility, but easily within range of small scopes. But you just see a faint fuzzy. But to see the sort of the contrast between the dark and the light side, you need a 10 or 12-inch minimum.
Okay.
Yeah, you can see it, and I've seen it in an 8-inch.
Okay.
But you have to have a dark sky.
How does this compare to the Ring Nebula, looking at it, you know, with a telescope?
Oh, this is much fainter.
Okay.
Well, is it dark facing us? We're seeing it at an angle.
Yeah.
Why is this side dark?
It's formed from a collision.
Yeah.
Oh. So it collided with another galaxy, and it's
like a dusty galaxy collided with it, or you know, with some progenitor of it, and they formed this galaxy.
Oh. So science has determined over years. Science has determined that galaxies, when they collide, usually just merge and become one, or do they ever pass through each other? And
they do all sorts of things.
Yeah.
Really?
Sometimes they pass through each other a couple of times before they merge.
Yeah.
Okay. And what do they think happened with good old M64 Black Eye?
Yeah, this one is called a Type 2 Seyfert galaxy because it has an X-ray source in the nucleus. It's considered an active galactic nucleus, meaning it has a black hole too.
Right.
But there's 2 disks here. There's an inner disk of molecular gas truncated at about 2,300 light years. At present, the non-rotational motions of this disk do not significantly feed the core, but the disk does produce a vigorous star formation.
And that disk is another galaxy?
Yeah, it has inside this disk. It's hard to imagine. This disk consists of 2 counter-rotating disks. Inside the dark part on inside is rotating one way. The arms are rotating another way. So with this chaotic motion, or this retrograde motion and stuff, it's
pretty dynamic.
Indicative of a collision.
Wow.
So it looks good like a single galaxy, but it's accreting out of a collision.
I wrote down a lot of stuff from your notes, Mr. President, but I don't think I got the distance. How many millions of light years? Meaning we're looking at it long ago, actually, but
60, maybe 60.
60
million, something in there.
Yeah, I think
the Virgo cluster is in the
58
ballpark
million,
60.
which is about 60.
Oh, here it says 17 million light years. So this is a close one.
Close.
So if they have computer programs that can go ahead to what today they figure out where it is today, would it be in the same general area, or would it be way over here somewhere else, even though we can't see it?
There's no point to figuring out where it is now because you can't see it there. It's only of academic interest.
Yeah. Well, you know how scientists are. We love to put up variations of things and depictions of things. Artist renderings.
Oh yeah, it has a diameter of 53.8 kilolight years, 53,800 light years.
Oh,
that's not what you asked, but
wait a minute, half the size of the Milky Way?
About that.
The Milky Way, they now estimate, is 200,000 light years across.
Yeah. Really?
Yep. Yeah, it depends where you define the edge, but yeah, we think we're bigger these days.
It gets kind of fuzzy, doesn't it?
Yeah.
Well, I thought Andromeda was about that size. That means it's got to get bigger now too, wouldn't it?
No,
We're
no,
still-
it's comparable. We might be a little bit bigger actually these days.
Yeah, and Ron, when you were talking about colliding galaxies, you know, the Andromeda's heading towards the Milky Way. There's some computer modeling of the two galaxies as they pass through each other, and that's when it passes through and comes back, and it does it 2 or 3 times. But you could look that up. It's really interesting.
And that won't happen during our lifetimes, will it, guys?
Nope.
In fact, it's going several hundred kilometers a second. It's moving. It's 2 million light years away, and we'll get here in 4 million light years?
4 billion years.
How soon will it get here? It'll be many, many, many years.
4 billion years.
Don't worry, you'll have your house paid off before then.
Get insurance.
Yeah.
Well, gentlemen, I learned a lot. I just wish I could keep it in there. Maybe some of it did stay. That was number 147. We've got 2 more meetings. In fact, the second one, 2 weeks from today, will be on Christmas morn. Most of us have agreed to get back on here. So the guys on my lower screen have maybe a week to go purchase your Santa hat so you can join the club here and really make everybody. Otherwise, we'll buy one for you and take it out of treasury funds.
I'm going to get one with a tree on it.
Yeah, I happen to know the new treasurer personally. She's married to one of these Santas on the screen. Give your loves to your wives, and doggone it, let's get together again for number 148 next week.
Thank you.
On the SBAU Astro Hour. Ho, 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 and Merry Christmas, everybody.